Okay, so before I start, here are my disclosures. Okay, I already mentioned artificial intelligence and ChatGPT. I have to say I am fascinated with ChatGPT or intrigued with ChatGPT. And when I was preparing the lecture, I asked the question which I was asked to answer: can food allergy in children be prevented? And I asked to provide an answer, and as you can see, ChatGPT says currently there is no way to completely prevent food allergies. However, and some strategies were suggested. But I ask yes or no. And the ChatGPT says, no, currently there is no guaranteed way to prevent food allergies in children. So in a way, I should stop my presentation here, but I would like to add some human touch to this presentation. And I would like to, this is the outline of my presentation. I will talk about food allergy prevalence, whether it's increasing or decreasing. I will provide a very brief overview of food allergy prevention guidelines. I will talk about guideline adoption and impact on prevalence. I will talk about early peanut exposures in different risk groups, not only high-risk population. I will talk about early or very early calcium protein exposure, amount of allergenic foods consumed, and research gaps. And in my presentation, I will try to focus on the last 3 years. So let me start with the first question: food allergies, are they increasing or decreasing? Look at the map which is on your right side, and you will see gray zones. These are the areas that we don't have any information. But we do have from other parts of the world, mainly from developed for high-income countries, but also, even if more limited, from low and medium countries. And let me summarize those data. And we can say food allergies are definitely increasing, especially in developed countries, but also in many of low-income and middle-income countries. Estimates depends on diagnosis method and population studies. So there are variations. This is very important. Self-reported rates overestimate the prevalence compared to rigorous diagnosis. It was nicely shown in a systematic review published now from Europe, and it's threefold increase in self-reported rates. But if you look at the strictly confirmed diagnosis, it remains more or less the same. And common food allergens may vary between regions. In the European study, the systematic review published like a year ago, there were many questions: a real increased awareness, increased number of food allergens assessed, or maybe increased number of studies from countries that had less data in the first review. Well, but if it's true that food allergies are increasing, the question is why food allergies are on the rise. And genetic definitely plays a role. And there are many new data on new genes, new loci, new mutations. They are important, but they are not sufficient. So a number of hypotheses has been suggested to explain why food allergies are on the rise, including the dual allergen exposure hypothesis, which I will discuss briefly in a while. We know that food allergies pose a huge burden on individuals, on families, on societies, on healthcare systems. And therefore, we all agree that prevention is better than cure. And this brings me to the second part of my presentation, brief overview of food allergy prevention guidelines. And let me start with a systematic review which was published recently, review of guidelines published in the last 30 years. And what is important, I will not go into the details, what are the major changes in the guidelines? So first of all, population of interest. Earlier, the interest was in high risk only. High risk means mother, father, or sibling with documented atopic disease. Now we are interested in high risk, but also in general population. The risk definition have changed. From family history, as I already mentioned, what does it mean, to infants' own risk. We know that infants with eczema, with egg allergy, have higher risk of peanut allergy. And finally, the huge shift in the guidelines is regarding potentially allergenic foods, from avoidance, which we were recommended for many years, to no need or for avoidance and active introduction. And I already showed you that there's this dual allergen exposure hypothesis, which is taken into account for the rising prevalences of food allergy, which says that the route of allergen exposure matters. If this early allergen exposure is through skin, especially damaged skin, this will lead to T cells skewing towards Th2 response, interleukin-4, interleukin-5, interleukin-13, and may contribute to the development of allergy. If the early allergen exposure is oral, then T cell skewing will be towards Th1 and T regulatory cells, and it can contribute to the development of tolerance. So this is a hypothesis upon which a number of studies was done, including a very important study, LEAP study, which evaluated early peanut introduction. Early means from 4 to 11 months of age. Everyone, I am sure, knows in the audience the results of this study. There was a striking difference, striking reduction in the risk of peanut allergy. And I like this comment. This was a landmark study which resulted in definitive changes in infant nutrition. And indeed, if you look at more recent guidelines, and this is a comparison of guidelines published in the last 2 or 3 years, you will see there might be some differences in the population of interest. How we are saying what is the early age of introduction, around 4 to 6 months. Sometimes it's more specific, sometimes less specific, but the guidelines are quite consistent. Let me very briefly talk about one of those guidelines, those developed by IACI. I come from Europe. The guidelines were developed by European Academy for Allergy and Clinical Immunology. Susan Halken from Denmark is the first author, and together with Gary Wong, who is the next speaker in this session, I had the privilege to contribute to those guidelines. And there are 3 sets of guidelines, frankly speaking. Recommendations supporting interventions, recommendations against interventions, and no recommendations for or against. So, and let me just very briefly summarize those. So recommendations supporting interventions. Egg as part of complementary feeding, so around 4 to 6 months to start to introduce. Peanuts as part of complementary feeding in high-risk population. National guidelines should be developed according to this document because studies were mainly done in the population with high risk, in UK, with high risk of peanut allergy. And what is important, avoiding cow's milk-based formula in the first week of life. Limited evidence, but here's a recommendation. Recommendations against interventions. This is against diet during pregnancy on lactation and the use of soy formula. And a number of interventions for which there is no recommendation for or against because there was not enough evidence to formulate recommendation. Breastfeeding, which has many benefits but does not prevent allergies. Regular cow's milk-based formula after the first week of life, so different recommendations depending on the timing. Hydrolyzed formula, no recommendation for or against for prevention. And vitamins, fish oil, probiotics, prebiotics, and symbiotics. So takeaways from this part of my presentation is there is a clear paradigm shift in the guidelines for food allergy prevention. While some differences in the specific recommendations exist, overall the guidelines emphasize early introduction and regular consumption of potentially allergenic foods. This brings me to the next part of my presentation, which is a guideline adoption and impact on prevalence. We do have guidelines, but we don't want to know whether they are followed. Limited data are available. I'm showing you the data from US, quite recent data. The physicians, pediatricians, and allergists were aware of the guidelines, but full implementation in only amongst allergists, 64%. In the pediatricians, 29%. For caregivers, again, limited data, but recent data from US, caregivers, egg, at 12 months, 59%, peanuts, 66%. So not everyone is following the guidelines. Much better in Australia, and what is important for Australia, there has been documented, there is a shift in the guideline uptake. There is a new guideline and the data from before and after the change of the guidelines, which are important for what I will show you in a moment, because an important question is, we do have guidelines, but does giving infant peanut lower their peanut allergy risk? And this is a very important study which was published in JAMA with a comparison of 2 Australian cross-sectional samples before and after guidelines that recommended early peanut introduction. And as you can see here, the 2 cohorts were health nut and early nuts before and after the change of the guidelines. And you can see there is reduction in the risk, but not statistically significant after standardization for ancestry and other demographic. And ancestry in this study matters because, as you see, not ethnicity, but ancestry. Ancestry matters, and in infants of Australian ancestry, there was reduction. But in infants of East Asian ancestry, there was no significant difference. This was, of course, observational trials, but something for us to consider. And those disappointing results, of course, make question whether we should follow those guidelines on early peanut introduction. And this was editorial which was published, which was accompanying this paper. And I like the conclusion. Given the potential for benefit and the low risk of harm, the results of this important study should not dissuade clinicians from following current consensus guidelines that recommends early peanut introduction for infants. We still need data from other studies and probably a longer follow-up. We need more data, particularly consider that if you look for data from Ireland, different cohort compared in different countries. Infants born before the pandemic, so old guidelines were probably most likely still followed, and infants born during lockdown period. You will see, new guidelines were already implemented, and you will see atopic dermatitis at 2 years was higher in those second cohort, but peanut sensitization was reduced, statistically significant. Peanut allergy was also reduced, but the difference was not statistically significant. So it really shows more data from other parts of the world on guideline uptake and also on the follow as needed. Because data on the uptake of the guidelines is limited, and even in settings with high guideline uptake, such as Australia, recent evidence indicates that earlier introduction of peanuts may not lower peanut allergy risk at the population level. Definitely too early for the final conclusions, but this is an important study. Okay, now I would like to talk a little bit more about early peanut exposure in different risk groups. And the reason I want to discuss is because the studies on peanut allergy were mainly conducted in the or the guidelines are based on the studies which were conducted in UK, the country with high peanut allergy prevalence. And this is an important study which was published in Allergy on early introduction of peanuts in various risk groups. And this was pooled analysis of data from EAT study and LEAP study. And you can see this peanut allergy at 3 to 5 years of age. In intention to treat analysis, 75% reduction. In per protocol analysis, 98% reduction. They also look at the severity of eczema. And then no matter what was the severity of eczema, there was reduction. There was also reduction in the children without eczema, even the numbers, not statistically significant, but also the numbers were very, very small. Another important study, finding from the same study is that age of introduction matters. And you will see here increased efficacy of the intervention with earlier age of introduction, earlier, which means 4 to 5 years, 4 to 5 months, not years, 4 to 5 months of age. Important finding. Another important finding, which contributes to our discussion on the peanut allergy introduction, is a Prevent Adult study, randomized, factorial multicenter cluster randomized trial in general population. Scandinavian countries, Norway and Sweden, and this study shows that food allergy can be prevented by introducing common foods, peanuts, but also cow's milk, wheat, and egg from age 3 months, but this was mainly because of the reduction of the peanut allergy. Important study because it was in general population. So takeaway from this part of my presentation is available evidence suggests that early introduction of peanuts is a safe and effective way to prevent peanut allergies, not only in high-risk infants. And this is important for developing national guidelines because, like I told you about the IACI guidelines. In IACI guidelines, we are saying in high-risk population. So it's depending what is the baseline. But this is showing that also in the general population, the reduction of the risk may be, even if I also showed you what it means in real life. More data are again needed. Okay. Peanut allergy, this is something which is important in many countries, but in my country, peanut allergy is not a major problem. So people are much more often asking me a question about cow's milk and early, or I should say very early, cow's milk protein exposure in the context of allergy prevention. And if you look at the guidelines from various societies which are addressing this specific issue of very early introduction, you will see that only IACI, which really differentiates the first week and after the first week of life, there are generally no clear statements from and this very recent publication from Spanish Association of Pediatrics, not possible to draw clear conclusion. And the reason for that is that if you look at the data, and the summary, here's a very brief summary of randomized controlled trials and non-randomized controlled trials, you will see data are not consistent. So I would like for this presentation showed you what was published very recently, and I will start with the SPADE study. The SPADE study, the original study, was randomized open trial, a trial which was carried out in Japan in general population. And there was a very interesting intervention because all children were breastfed and received cow's milk formula in the first 3 days of life, and then they were randomly assigned to intervention group or avoidance group. An intervention group means they were breastfed and received cow's milk formula. And in the avoidance group, they were breastfed and, if needed, they received soy formula. And there was a striking difference in the reduction in the risk of cow's milk allergy at 6 months of age. As you can see, absolute risk reduction, 6%. And what I would like to show you, more recent data, is follow-up, subsequent subgroup analysis of participants who ingested cow's milk formula in the first 3 days of life. And it was the majority, 93% of this population. And this is, now I'm showing you the results, and you can see early cow's milk formula discontinuation, particularly in the first months of life, was associated with cow's milk allergy development in infants who received cow's milk formula in the first 3 days of life. And on the other hand, continuous cow's milk formula ingestion over the first months of life may represent a potential method for preventing cow's milk allergy development in early exposed infants because there was reduction in the risk of cow's milk allergy. Of course, caution is needed when interpreting this result. This is a follow additional analysis. It's not a randomized controlled trial. It's just a subsequent subgroup analysis, and some of the groups were very small. But this, I think, is important for our discussion. The second study, for this context, which I would like to discuss, Project Viva. And this is a cross-sectional study, a questionnaire study with parents reporting on adverse reaction to cow's milk. And you can see that the timing may matter. Highest was the risk of cow's milk allergy adverse reaction if the introduction of cow's milk was at or after 6 months of age or below 2 weeks of age. And neutral seems the introduction of cow's milk between 2 weeks and 6 months. Again, caution is needed when interpreting this result. This was an observational, cross-sectional study. It shows correlation, but definitely not causation. And finally, the COMET study, it's a prospective study with follow-up from birth to 12 months, where term infant general population, almost 2,000 participants, continuous exposure to cow's milk formula daily until 2 months, not 12 months. I apologize for the mistake, and comparison was exclusive breastfeeding. And again, you can see those, the exclusive breastfeeding, the risk of cow's milk allergy at 12 months was higher. And again, caution is needed when interpreting the results. You can just have a look at this very wide confidence interval. It was not a randomized controlled trial. But all those 3 studies are, in my opinion, they contribute to the ongoing debate about the early introduction of cow's milk as a means for preventing cow's milk allergy. However, the conclusions are limited due to a lack of randomization and confirmed diagnosis of cow's milk allergy using strict criteria, at least in some of those studies. So it's premature to make specific recommendations. In other words, the key question remains unanswered. If there is risk to introducing milk too early and the lack of benefit of introducing it too late, when is the time just right? So there is a number of questions which still needs to be answered. And now this brings me to the almost pre-final part of my presentation, amount of allergenic food consumed. There are some studies, including X study, and this is a lesson from each study, that the quantity of allergenic food matters. The mean weekly consumption of 2 grams of peanut protein and 2 grams of egg white protein, 4 grams of egg protein, was associated with the prevention. So it really that the quantity matters. And as you know, at least in some countries, in response to the change of the guidelines, products containing single or multiple allergenic foods have become available in some countries. And this is one of the studies which look at the doses of specific allergens in this early introduction of foods. And as you can see on this slide, there was significant, this is an example of peanut allergens. There was significant variability in allergen composition concentration and dose per serving in those studies. I'm just showing for peanut allergy, but it shows that one of the products, there was undetectable levels. So the takeaway from this part of my presentation is that standardization and stringent quality control of commercially available products are needed. And there's one additional comment for this. Well, I am really a little bit confused whether, or disagreed probably, whether we need this kind of products, because it may mean medicalization of allergy prevention. And introducing allergenic foods with everyday foods is relatively easy and safe. So this is probably something to be discussed as well. Okay, so you may ask, so where are we now when it comes to the topic we are discussing? I think all of us would love to see the article which ends with this conclusion. We believe this resolves all remaining questions on this topic and no further research is needed. Well, we are not, as you know, we are not there yet. There are many, many research gaps, and many of those gaps I already discussed in my presentation. And they are also included in that IACI document, like in many other, what are the research gaps. And one can say, we can also ask, as I asked at the beginning, ChatGPT, what are the research gaps? And this is what I've done, because I'm really intrigued by ChatGPT. And this is the answer. Optimal timing and dose of allergenic food introduction. Very true, I fully agree. Mechanism of food allergy prevention. I definitely agree with that. And finally, long-term efficacy of food allergy prevention strategies. Very much true. So many more studies are needed, including randomized controlled trials. But for randomized controlled trials, please remember, what happens in double-blinded clinical trials stays in double-blind clinical trials. So again, more studies are needed. And with this, I thank you very much for your attention. Thank you.